We're surrounded by this invisible world of microscopic organisms. And yeah, most of them are totally harmless, but some are genuine threats, capable of causing some really devastating diseases. So today, we're going to take a tour of the world of pathogens.
From something as simple as an insect bite to a fungus that's literally adapting to a warmer planet, these dangers are everywhere. So, how do they actually work? How do they get around? And what is it that makes each one so uniquely dangerous? Let's dive in and find out.
We're going to start with a vector that we are all unfortunately very familiar with, the mosquito. That tiny, buzzing pest is way more than just an annoyance. It's actually one of the most effective and deadliest disease transmitters on the entire planet.
Okay, so here's the game plan for this explainer. We'll kick things off with the threats delivered by mosquitoes. Then we're going to move into the terrifying world of hemorrhagic fevers like Ebola. After that, we'll look at the dangers hiding in a simple tick bite, and we'll wrap things up by exploring the invaders that take advantage of us when our own bodies are weak. Right, let's get into it. Mosquito-borne threats. An itchy bite might seem like no big deal, but what gets left behind? Well, that can be a whole different story. Let's just take the leading cause of mosquito-borne disease in the continental US, West Nile virus. Now this thing is wild because for most people, it's basically a ghost. A staggering 80% of people who get infected show no symptoms at all, which makes it a really silent spreader. It's only in those really rare cases, we're talking less than 1%, that it develops into a severe neurological illness. But, not all viruses are that sneaky. Some, like chikungunya, let you know they've arrived right away. And while it can cause a rash like this one, its most notorious symptom is something you can't see, but you can absolutely feel it. Chikungunya is all about the pain. It hits you with a sudden high fever, but what makes this disease so awful is the severe, debilitating joint pain. We're talking pain so bad it can knock you off your feet. And for some people, this isn't just a week-long thing. This agonizing pain can stick around for months, or in some cases, even years. And to make matters worse, there's no specific treatment or vaccine for it right now. So from a disease that causes lingering pain, let's zoom out a bit to a more global threat. I'm talking about dengue. As you can see from this map, it's a huge health concern across all the world's tropical and subtropical zones. This puts nearly half the global population at risk. They don't call it break-bone fever for nothing. That nickname tells you pretty much everything you need to know about the kind of pain it causes. But what makes dengue so unique and dangerous is this little twist. The real trouble often starts if you get infected a second time. That's when your immune system can actually go into overdrive, causing the disease to become a severe, life-threatening hemorrhagic fever. And that term, hemorrhagic fever, brings us to our next section. These are some of the most feared viruses on the planet, and for good reason. They're known for their ability to cause severe disease in multiple organs, and just like the name suggests, internal and external bleeding. And here they are, two of the most infamous cousins in this family, Ebola on the left and Marburg on the right. They're both what we call filoviruses, and you can see why. They get their name from that long thread-like shape. And they both cause these rare but often fatal hemorrhagic fevers in people. If you look at the history of Ebola since it was discovered back in '76, it's a story of these sporadic but absolutely devastating outbreaks. In big events like the ones in 1995 or that massive West African epidemic back in 2014, the mortality rate can be just incredibly high, anywhere from 25 all the way up to 90%. So how do these viruses even make their way to us? Well, the pathway for Marburg here shows a really common pattern. The natural home, the reservoir, is the Egyptian fruit bat. From there, it can spill over to other animals, or sometimes directly to humans who happen to come into contact with bats in places like caves or mines. And once it's in the human population, it spreads through direct contact with bodily fluids. Marburg's origin story is just fascinating. It wasn't discovered in some remote village, but in labs in Europe. The very first outbreak happened among lab workers in Marburg, Germany, that's where it got its name, and also in Belgrade, Serbia. They were exposed through a shipment of infected African green monkeys. It's just a starting reminder of how interconnected our world really is. All right, let's switch gears a bit. We've talked about viruses. Now let's talk about bacteria. And we're moving from mosquitoes to another tiny vector with a nasty bite, the tick. These little arachnids can transmit a whole menu of different diseases. Yeah, if you ever see this on your skin, you need to pay very close attention. This is the classic bullseye rash, and it's the most recognizable sign of Lyme disease. It's caused by this corkscrew-shaped bacterium transmitted by the bite of an infected black-legged tick. Now, the absolute key with Lyme is catching it early. In that first month or so, you might just have the rash and some flu-like symptoms. But if it goes untreated, weeks or months down the line, it can lead to much more severe problems, including chronic arthritis, serious neurological issues like meningitis, and even heart problems.
But ticks don't just carry Lyme, right? There's also Rocky Mountain spotted fever. The key signs you want to watch for here are a really severe headache and a high fever. A few days after that, a rash usually shows up, and characteristically, it starts on the wrists and ankles. Thankfully, this one isn't contagious from person to person. Okay, get ready for one of the absolute weirdest things a bug bite can do to you. A bite from certain ticks, like the Lone Star tick, can actually make you allergic to red meat. No joke, the tick injects a sugar molecule called alpha-gal, and for some people, their immune system flags it as an enemy. And the result? A brand new and potentially severe allergy to things like beef, pork, and lamb.
All right, for our last section, we're going to look at a different kind of threat. We're not talking about an invader from the outside world, but one that's, well, already inside of us. These are the opportunistic pathogens, microbes that are often just hanging out in our body's ecosystem, waiting for the perfect moment to cause trouble. So let's look at a tale of two yeasts. On one side, you've got Candida albicans. It's a super common fungus that lives in our gut and mouth. Usually totally harmless. But if someone's immune system's weak, it can overgrow and cause infections like thrush. But then you have its relative, Candida auris. And this one is a whole different ballgame. It's a serious, emerging global health threat, mainly because it's often resistant to multiple antifungal drugs, and it spreads like wildfire in hospitals. And if you want to see what happens when an opportunist like Candida albicans gets the upper hand, well, this is it. This is oral thrush. It's a perfect visual of what happens when our own internal flora gets thrown out of balance and causes disease, usually when our immune defenses are down. So you have to wonder, why is this much more dangerous C. auris really emerging now? Well, one of the leading theories is both fascinating and, honestly, a little unsettling. Scientists think that as our planet has warmed up, this fungus might have adapted to survive in higher temperatures that are closer to that of the human body. And this adaptation might have been the thing that allowed it to make that jump from being a simple environmental fungus to a really tough human pathogen. And this brings us to a final and really crucial question. The story of Candida auris is this powerful reminder that the world of pathogens isn't standing still. It's constantly evolving, it's reacting to the world around it. So as our climate continues to change and habitats keep shifting, it really makes you wonder, what other invisible dangers are out there, adapting and just waiting for their moment to emerge?